Hello students. Today we will learn about friction. This is unit 5 of your subject engineering mechanics. The course outcome we are trying to achieve here is you will be able to apply the principles of friction in various conditions for useful purposes. Prerequisite to learn this are concept of force and resolution of forces. So I'm presuming that you are familiar with these two concepts. Okay, now this is the summary of this lecture. First, you will learn about concept of friction, then types of friction, limiting friction, then some technical terms like angle and coefficient of friction, angle of repose, then laws, advantages and disadvantages of friction. Remember, we are only covering theory part of your unit 5 in this video. For example, I will be sharing another video. Okay, so let us start with concept of friction. So, to understand the concept of friction, pay attention to this figure here. So, you have a lower body and an upper body, and you are trying to move this upper body with force P, right? So, what are the forces in picture here? First is there will be some weight W of this upper element, and there will be a reaction from the lower element against this weight W. So, you have a downward weight W and upward normal reaction. Then you are trying to pull this with force P, and there will occur a reaction between two surfaces that will be your frictional force. So, by definition, the concept of friction or frictional force is when a body moves or tends to move over a surface, resisting force is developed opposing this motion. This resisting force is called frictional force. Okay, when a body moves or tends to move over the surface, resistance is developed against the motion. Okay, now this occurs due to imperfection of both surfaces. However smooth the surface may appear, there are always some imperfections on the surface, and there are some projectile particles also. So, an interlocking takes place between projecting particles of two surfaces, which causes resistance to sliding or rolling. There are two ways of moving a body over another. First, you can slide it or you can roll it. So, the resistance is developed against the sliding or rolling due to the interlocking of projecting particles of two contacting surfaces. So, this is basic concept of friction. Next, we will see some types of frictions. So, there are two main types. First is static friction, and the other is dynamic friction. Now, it is clear by the name only that static friction deals with bodies at rest, and dynamic or kinetic friction deals with bodies in motion. Now, there are two subparts of this dynamic friction. First is sliding, and other is rolling friction. When you try to slide a body over another, you get sliding friction. When you try to roll it over, you get rolling friction. Dynamic friction is always less than static friction. Then there is a dry friction. So when there is no lubricant used between two surfaces, friction is called solid friction or the dry friction, or another name is Coulomb friction. So these are basic types of friction: statics, dynamics. Two parts of dynamics, those are sliding and rolling, and then there is dry friction. Okay, now we will move to some technical terms. First term is limiting friction. So pay attention to the graph here. It is a plot of friction versus applied force. So we know that a friction force is passive and self-adjusting force. Okay, what do you mean by passive force? That means that friction force does not exist independently. It always exists when you try to move a body. So it acts against the motion and against the force you are putting to cause that motion. So as and when you apply this force P, okay, and you start increasing this force P, you get friction, and friction also increases accordingly up to a point. When you reach condition of impending motion, any slight increase of force P beyond this point will cause motion, and when the body starts moving, the friction force suddenly drops. The friction force suddenly drops, and then the friction force is constant in the kinetic range. So you are seeing two main parts of this plot. First is static condition, when body is not moving, it is resting, and then there is kinetic condition, and when you move from the static to kinetic condition, there is sudden drop in friction, and what is the maximum friction you can get in this condition of impending motion is called your limiting friction, right? So frictional forces, first it is passive force. It acts as a reaction to your applied force, and it is also self-adjusting, so it will increase according to the increase in your applied force P. So, by definition, maximum value of friction force which exists when a body just begins to slide over the surface of another body is called limiting friction. The maximum value of frictional force you can get in the static condition is called friction, limiting friction force. Okay. Next term is angle of friction. To understand this angle of friction, you will need to consider this, that there is a rough surface here, rough horizontal surface. There is a rough block resting on this surface. So now see how many forces will be acting in this system. Very first force you can draw is this W, weight of the block. Okay, this block will contain some weight and it will be acting vertically downward. So first is this weight, next is this normal reaction which acts opposite to the weight, okay, which acts normal to the surface in opposite direction to this weight. So it is acting vertically upwards here. So one is W, action is W, reaction is normal reaction N. Next is you are trying to slide this body with this applied force P. Okay, you are putting this tractive or applied force P and you are trying to slide this block along the surface. So the frictional force will be developed opposing the motion, opposite the motion. So this is your direction of motion. The opposite to that will be your frictional force. So again, this is your action P and this is your friction, that is reaction to that action. So these two are in a way reaction to applied forces. Okay, N and F are reactions. So you will need to find total reaction of these two. That means resultant of this two. So this R force is resultant of this F by N. Okay, you get it by simply consider, you get it by parallelogram method. Okay, you complete this rectangular parallelogram and the diagonal is your resultant force. So this is your total reaction R. And the angle between this total reaction R and normal reaction N is called angle of friction. And we have assigned symbol phi to it. Symbol for this is phi. So, angle of friction is defined as an angle which the resultant R of normal reaction and limiting force, a force of friction, makes with the normal reaction. So, resultant between R and N is called phi. But to understand what is this force R, you need to understand this whole figure and all the forces acting on it, right? Also, when you get 10 of phi, you get opposite side, that is F, and adjacent side, that is N. So 10 phi is equal to F by N, opposite by adjacent side. That will be your 10 of angle of friction. So again, angle of friction by definition, it is defined as the angle which the resultant R of normal reaction N and limiting friction F makes with the normal reaction N, and it is denoted by phi. Next is coefficient of friction. So coefficient of friction is defined as the ratio of limiting force of friction to the normal reaction between the two bodies. It is denoted by mu. Okay, so there will be a ratio between F and N, and you will call this coefficient of friction mu. Okay, mu is equal to F by N, and also we know that F by N is 10 phi. The value of coefficient of friction is high for rough surfaces and low for smooth surfaces. Now let's understand angle of repose. So angle of repose is maximum angle at which block is resting on an inclined surface without sliding down is called angle of repose. Now let us understand this with this figure. Here our surface is not horizontal, it is inclined at an angle alpha with horizontal. Now as you try to increase this angle alpha, the surface becomes more and more steep, and as you increase this angle there comes a point when block starts sliding down the surface. Right now what is happening is the friction between block and the surface is stopping the block from sliding down the surface, but when you keep increasing the angle alpha and keep making this slope more and more steep, you get a point when the gravity overcomes the friction and the block slides down. So to understand that, let's consider all these forces. So uh, first force will be the weight of this block. Okay, weight will always act in vertically downward position. Then there will be reaction to this weight, which will be normal to the surface. It will not be vertically upward, like opposing the this W directly. It will always be normal to the surface, because it is the surface that is causing that reaction. So if surface is in this direction, N is normal to that. Okay, then what is the direction of motion? It is downwards due to gravity. So what will be the direction of friction? It will be upwards against the motion. So this is your force F working upwards, stopping the motion. Now we will resolve this force W in two components. First along the surface, other is perpendicular to the surface. For that we need this angle. So if this is alpha, this will be alpha. Okay, you turn these two lines at 90 degree and you get these two lines. So if this is angle alpha, this is angle alpha, this is adjacent side, so we call it W cos alpha, and this is opposite side, so we call it W sin alpha. So these are all the forces acting on this system. First is W sin alpha, W cos alpha, then N, and then F. These are the forces. Now, considering the forces along and perpendicular to the plane. So, let's see first along the plane. So, parallel to the plane. Okay. So, first is this frictional force F, which is acting parallel to the plane going in upward direction. Then there is sine component of this W, that is W sin alpha, which is coming in downward direction. So, by the condition of equilibrium, we can say that this F is equal to W sin alpha, because there is no other force acting parallel to the surface. So F will be equal to W sin alpha. Then let's see perpendicular to the surface. Now perpendicular to the surface, again forces are acting. First is this normal reaction N, other one is W cos alpha. So we can say that N is equal to W cos alpha. This is the equilibrium condition in the normal direction. So N is W cos alpha. So we get these two equations. First is F is equal to W sin alpha and N is equal to W cos alpha. Now divide these two equations. You get F by N is W sin alpha by W cos alpha. Simplifying this, cancel out this W and you get 10 alpha. So you are getting F by N is equal to 10 alpha. But from previous concept of angle of friction, we know that mu, that is coefficient of friction, is equal to 10 of phi, that is angle of friction, is equal to again F by N. So we can say that 10 alpha is equal to 10 phi. 10 alpha is equal to 10 phi. That means alpha is equal to phi. So in limiting equilibrium conditions, you can prove that angle of repose is equal to angle of friction only in limiting equilibrium condition, right? And again, what is angle of repose? It is the maximum angle at which the block is resting on an inclined surface without sliding down. Okay, maximum angle at which the block is not yet sliding down is called angle of repose. Now let us understand laws of friction. Okay, so first we will see laws of static friction, then dynamic friction. So laws of static friction are: the frictional force always acts in a direction opposite to that in which the body tends to move. In static condition, the movement has not occurred yet, but friction will act in the direction opposing to the uh, direction in which the intended movement is there. Okay, then we know that friction is a passive force. So P is equal to F. As you increase the applied force P, F increases. So P is equal to F only in static condition. The frictional force is directly proportional to the normal reaction between the surfaces. Okay, so F is proportional to N. Frictional force is proportional to normal reaction. Next is the frictional force depends upon roughness of surface in contact. Okay, it depends on the roughness, the quality of the surface in contact. The frictional force is independent of the area and shape of contacting surfaces. It does not depend on the area and shape of the contacting surfaces. It only depends on the roughness of the surface. Then there are laws of dynamic friction. So the frictional force always acts in a direction opposite to that in which the body moves. Now in dynamic condition, now it does not tend to move. Body is already moving. So friction acts against the motion. The frictional force is directly proportional to the normal reaction between the two contacting surfaces. It's the same for static and dynamic both. F is proportional to N. And last one is the frictional force remains constant for moderate speeds, but it decreases slightly with the increase of speed. So kinetic friction is constant only up to the moderate speeds. If you increase the speeds exponentially, the frictional force decreases slightly. Okay, so these are the laws of friction. Last point is advantages and disadvantages of friction. These are very simple terms. So what are the advantages? We can walk on the floor without slipping. It is due to friction between shoe and the floor. Okay, vehicles can move safely due to friction between tire and road surface. Nails and screws are fixed into the wall. It is also due to friction. We can rest an inclined ladder on the wall. It is also due to friction. Right? And what are the disadvantages of friction? Your machine parts and tires are worn out, heat is produced, and noise is produced. These are the disadvantages of friction. So this much is in the theory part of your unit 5 friction, right? So thank you for listening.